A new version of Rust has been released and the long-awaited 2024 edition of Rust is finally here. Before diving into the 2024 edition, let's talk about the important new features in this release. The first feature I want to talk about in this release is async closures. Before this release, if you wanted a closure that could execute asynchronous code, you could define a regular closure that contained an async block. But the problem is if we tried to reference any values stored outside of the closure, like this vector here, then we would get an error. Well, as of this release, instead of defining a regular closure that contains an async block, we can simply define an async closure. This code compiles because async closures allow us to capture values from the local environment similar to async functions. In this release, we also got 3 new closure traits: async fn, async fn mute, and async fn once, which are the async complements to the synchronous closure traits fn, fn mute, and fn once. And we can use these new async closure traits to define higher ranked function signatures. For example, here we have an async function called f. It accepts a closure, which in turn accepts a reference to an unsigned 8-bit integer, and returns a future. Then we have another async function defined called f2, which also takes in a closure that returns a future, but defines it by using the async function trait. Now, if we scroll down to the main function, we can see that we can call both f and f2 by passing in g, which is a closure that contains an async block. But let's see what happens if we try to pass in g2, which is an asynchronous function. As you can see, f is not able to accept a function pointer, whereas f2 can. So as you can see, these new async closure traits are more flexible and should be used instead of manually specifying that a closure returns a future. The second feature in this release is hiding trait implementations from diagnostics. Imagine you're a library author, and in your library you have 2 traits that you publicly expose, a trait called foo and a trait called bar. And then you add a blanket implementation of bar for any type that implements foo. Now imagine a consumer of your library defining a custom type, in this case my type, and then they attempt to create a trait object. In this case, the trait object represents any type that implements the bar trait. If we look at the compile time error we get, it'll say, the trait bound myType::bar is not satisfied. In other words, myType does not implement the bar trait. But then it goes on to suggest that the foo trait should be implemented for myType. And this is because if we implement the foo trait for our type, then the bar trait will automatically be implemented because the bar trait has a blanket implementation on any generic type that implements foo. The problem is, as a library author, this may not be what we want. Maybe we want consumers of our library to implement the bar trait directly instead of indirectly by implementing the foo trait and then getting the bar trait automatically due to this blanket implementation. If that's the case, we can now add this extra annotation to our blanket implementation. Diagnostic do not recommend. And now if we run the code again, you'll see that we still get the same error, the trait bound myType::bar is not satisfied, but now the compiler will suggest implementing the bar trait directly on myType. Implementing the foo trait is no longer being recommended. Personally, I think this feature is great because it'll help clean up error messages and avoid confusion. The third feature in this new release is that FromIterator and Extend is now implemented for tuples up to 12 elements. These traits allow a tuple to be split up into multiple collections. In this example, we take a tuple and then split it out into 3 separate collections: a vec_deque, and a linked list. Now let's talk about the 2024 edition of Rust. Now, if you're watching this video right now and you create a new Rust project, you'll notice that the edition is set to 2024 by default. The 2024 edition of Rust was just released, so what's included in this new edition? First, let's talk about some exciting borrow checker improvements. Here we have a function which accepts a value that's going to be a reference to a read-write lock that contains an optional boolean. The first thing we do is acquire a read lock to see if the optional value is a sum variant. And if it's not the sum variant, then we're going to get a write lock and then update it to be a sum variant. Now, the problem is, before the 2024 edition, this read lock up here would actually be dropped at the end of this entire if-else block, which means if we try to acquire this write lock in the else branch, it would cause a deadlock. In fact, if I go here and set the edition to 2021 and I try to run this code, you can see that it will keep executing indefinitely. Now, if I switch the edition to 2024 and run the code again, Then you can see that it finishes compiling because we no longer have a deadlock. This is because in the 2024 edition, the read lock that we get up here is actually going to get dropped before the else branch, which is what you would expect. The second borrow checker improvement has to do with temporary values created in tail expressions. Inside this function, we wrap a string value in rough cell and then call borrow to get an immutable reference to that string, and then the length method to get the length of the string which we return. Now, you might be surprised that running this code results in a compile time error. It states that this borrowed value does not live long enough because C is dropped before the temporary value created by calling the borrow method is dropped. But if we switch to the 2024 edition and rerun this code, besides a few warnings, you can see that this code compiles successfully. This is because in the 2024 edition, the temporary value is dropped first before C, which again you would expect. Next, let's talk about some unsafe Rust improvements in the 2024 edition. The first being that extern blocks are now required to be marked with the unsafe keyword. This makes it clear that it's the responsibility of the author of the extern block to make sure that the signatures are correct. If the signatures are not correct, then it could lead to undefined behavior. That said, individual items within an extern block can be marked as safe, which means they could be called without an unsafe block. For example, this square root function is marked as safe because it could be called with any 64-bit floating point number. However, the string length function is marked unsafe because it requires a valid pointer, which is an invariant that we can't guarantee through code. And if a function is not marked safe or unsafe, conservatively it will default to being unsafe. Another change in the 2024 edition is that certain attributes like export name, no main goal, and link section need to be marked as unsafe to indicate that they have soundness requirements that need to be upheld. Now, another feature in the 2024 edition of Rust is reserving the gen keyword. So if we try to create a variable and set the name equal to gen, you'll see that we get an error. And that's because the gen keyword is reserved. It's reserved because it will be used to create generators in the future. Generators would allow us to create complex iterators in a simplified way. I've made an entire video about the feature, so if you haven't seen it, make sure to check it out. Other changes include adding the future and into future traits to the prelude, and the ability to control which style edition Rust format uses. If you want to learn more about using these new Rust features, make sure to get your free 4-day Rust training at letsgetrusty.com/bootcamp. And then click here to watch this video next, which YouTube thinks you'll love. I'll see you in the next one.